today's event?
I'll tell you the motivation why I did this event. See, I work in many countries and I look at lot of collaboration and I've been visiting many countries and look at all the best sciences and best technologies. What I feel like always is important for our students and scientists to get trained in this area and try to reach the similar platform what people do at Harvard, Stanford, MIT and all the top labs in the world. So advances in photonic technology APT is meant to bring all the recent advances in this field so that all my students here and scientists here can try to get those training and try to use the skill what they have to empower them for doing research. So first of all, motivation was to really empower people and train people and make a good strong foundation for our country. And when I started doing that, then I think our entire should I continue or should I continue? Alright, so once I started doing it, I realized that there was huge interest among the students, among the participants, and lots of scientists and collaborators, clinicians, every industry heavily supported this event. So of course, like it was in my mind already a big hit because we have 16 countries people participating in this event. Scientists coming from almost 90 scientists from 16 countries and several hundred and thousands of students and participants are here. So it was a good satisfaction and a big hit in a way that to begin with. But I feel very satisfied that how the response are coming now and let's hope that it is going to be useful for many collaborations to come. Many of the scientists who are coming here, they will open up new projects, new opportunities for us in the future. So let's hope for the best from the activities for the future activities.
So we do see yourself and the event which is going evolving year by year. In the next 10 years, sir, क्या expect कर रहे हैं?
Well, I'm very happy that if our people are publishing to the same top journal what anybody from the top US lab publishes, right? Aim is to really train people, empower people. We are doing the workshop for that purpose. So I'm very happy to see that we are at equilibrium after a few years in that.
Wish you all the very best and thank you so much.
So thank you so much for discussion about it and all of your support. Thank you.
So we'll start with the introduction first. Tell us something about yourself, and then I'll ask you a few questions.
Okay. Hello, my name is Jens. I'm a professor of translation for Omics, also from Sweden. I work at the Science for Life Laboratory out of the Human Protein Atlas project, and my main research interest is in studying the human protein circulating in blood.
Okay. So what do you want to say about this event that we are attending today, that Mood Omics? What was the first thing that came to your mind when you heard that name, Mood Omics, and how do you associate with your technique or your technology that you have created?
Yeah, so I mean, Mood Omics is of course a mix of emotions, I would say. It brings a lot of color, a lot of movement and experience, and I think also it expands the perspectives that we gain when we work in different environments, when we present ourselves to different things, and I think it's really an experience that will of course resonate for a long time.
So what's this technology that you have created, understanding if you get cancer with different blood, we would like to understand more about that. Can you please tell us?
Yeah, so what we are doing at the moment is to analyze small drops of blood that we ask the person to donate themselves. And so we send these cards to the person's home instead of them having to come to the hospital or the doctor's office. And then we try to measure as many proteins as we can to investigate whether there are signals that a person is getting sick. For instance, if there's early signs of cancer, or if they are not responding to a treatment, or if the treatment is actually doing harm.
And where do you see yourself evolving in the next 10 years? This technology, how do you see it evolving all over the years?
Yeah, I think it will maybe become a routine, so we can actually test the whole population, and not only those that are coming to the hospitals because they are already sick. I think that's a big problem, because when you are already sick, it's much more difficult to treat the disease, for example, cancer. But if you routinely get a deep health check with deep information, then I think you will have much bigger chances to pick, for instance, the disease when it's just about to start. So that's of course one thing, and then you can go in with a more personalized treatment to really prevent that the disease starts. So that's one thing. And the other thing is, of course, if people are already taking medication, you can go in and check how are they actually responding to the medication when you think about the disease. disease, but are there any side effects? Can you reduce the side effects so that the person is feeling better?
So you're wishing you all the very best and thank you so much.
Thank you so much. Thank you. Thank you, guys.
First of all, we'll start with your introduction. Tell us something about yourself, first of all.
Okay, my name is Joshua LeBaire, and I am a professor at Arizona State University in Arizona in the United States. My background, I'm a medical oncologist, so I'm a cancer doctor, and also I'm a biochemist that studies how molecules contribute both to disease and how we can use those molecules to find disease.
Okay, all right. And sir, I mean, you're here in IIT Bombay, one of the most reputed colleges in India. You know, coming over here, have you come before over here, and or is this the first time you've been here?
This is actually the fourth time that I've been in India now.
Okay.
I've been to IIT Hawaii a couple of times, and then also I've visited a couple of other places like in Delhi and elsewhere. But I do enjoy it, especially here in Bombay.
Okay, fantastic. So tell us something more about this event which is happening today in IIT Bombay, which is in Omics. So what does it say about, and how you have become a part of this thing, and tell us something more about your contribution to the event.
Yes, so I think it's important to think about what we mean by Omics and what that represents, and it really is a revolution in science. In the last century, in the 20th century, it was the century of the microscope. We looked at things under a microscope and used that to tell us about what we were looking at. But in the 21st century, it's really the century of the molecules. And we look at molecules, there are millions of them, and they tell us all kinds of important things about diseases, what causes the diseases, how do we find the diseases, and omics is a reference to how we measure all of those molecules. In the old days, we would measure one or two of them at a time, but nowadays, we look at many of them all at the same time. In my case, my lab's interest is in looking at many proteins. And so we've devised a molecular array system called a protein array that displays thousands of proteins. And we can probe those with blood from patients to see if we can use those to help identify diseases. Other people are looking at gene expression, or they are looking at the structure of chromosomes, or at metabolites in the blood, but all of those together make omics, and Omics is a celebration of the value of these omic approaches to solving biology and advancing medicine.
So in the next 10 years, where do you see this technique, I mean, in India, in world, how it's going to develop more and more, helping people all along?
Yeah, so Omics is going to change the way medicine is practiced in the next 10 years. In the old days, when I was first trained as a cancer doctor, there was only one diagnosis of breast cancer. It was ductal carcinoma of the breast. And there was really one therapy for it. Nowadays, we already know there are 5 at least, and maybe more like 10 different subvarieties. And we're already employing that in which drugs to use for patients and how to treat them best. In the next 10 years, that's going to get even better. We're going to get even more specific about identifying diseases, understanding the medical causes, and then coming up with therapies that very selectively treat those. Already, we are seeing decreases in mortality among many cancers because of all these molecular therapies, and I think that's going to continue even more. So I think this whole Omics is really going to contribute to huge advances in medical therapy.
Fantastic. You're wishing you all the very best, and thank you so much.
Thank you so much. Yeah, it's a pleasure.
A number of technologies, and I think in the last decade we've seen a burgeoning of new technologies that allow us to address important questions in genomics and proteomics and metabolomics. Some of them are based on mass spectrometry, a device for finitely measuring accurately small amounts of proteins, but extended to other methods as well. So I think it's really exciting that the field really has expanded the whole range of new technologies, and they're being represented in the meeting here.
And in the next 10 years, how do you see these technologies helping the world in a way? So what are your thoughts on that?
Yeah, so I mean, there's no doubt that we have a very large population in the world, and a significant proportion of that population population, and any time is not well. At times we're all patients, we all have disease, we all need treatments, and at the moment those treatments are good, but they could be much, much better. And so I think these new technologies offer us the hope of improving the treatments that we've got, and to do that precisely, to do that focused on the individual rather than just the population or people with a specific disease. So focused on the individual, to do it very precisely. And I think that one of the things that we get particularly excited about is the possibility that in the future we may be able to use these technologies to diagnose diseases much earlier, intervene before the disease fully emerges. So that's more preventative. So I think that's a really exciting possibility for the future.
Wishing you all the very best, and thank you so much.
Thank you. Thanks.
We'll start with your introduction. Tell us something about yourself and your, what are you into, and then I'll ask you.
Alright, so thank you for the interview. My name is Bernd Wolscheid. I'm from the Institute of Translational Medicine at IIT Zurich, and I got invited by Dr. Sanjeeva to present at your awesome symposium over here, APT 2025.
Okay. So what is this event all about? In your own little word that people can actually understand. What is this mood omics, and what are the technologies that we are going to see today and what we have seen?
This is an awesome event Dr. Sanjeeva is organizing now for a number of years. It brings together the community, the worldwide community interested in omics technologies. It allows us to connect not only with Indian scientists, but also, as we saw in the morning, with the next generation of scientists. So that was actually quite amazing. All the school kids that came over, and we gave a number of TED Talks in the morning to kids from different schools. I had a number of discussions afterwards and got them excited about the technology, about the impact of the technology, and how we can take the technology to the next level for the benefit of patients.
Any specific specialization that you like over here? I mean, any specific technology that you want to share with us? What's the best thing about this particular event that you are doing?
Yeah, certainly. I mean, the event is focused on also proteomic technologies as one of the omic technologies, and as you saw from the presentation of Stephen Pennington and also from Josh LeBaire, it's about cancer, it's about eventually finding new biomarkers. It's about the idea that we can take technology into the clinic and for the benefit of patients.
Thank you so much, and all the best. Thank you.
Thank you.
Okay.
We can look at this end. Just basic about this event and about your profiling that.
Okay.
Rich? Yeah.
My name is Judith Steen. I am an associate professor at Harvard Medical School, and I study how the brain ages and how it ages badly in some conditions. When I was growing up, my amamma lived with us, and she had Alzheimer's treatment. So my name is Judith Steen, and I am a professor at Harvard Medical School, and I study neurodegeneration. And as a child, I grew up with my amamma being in the house with Alzheimer's disease, and it affected me a lot. I saw her lose the person she was, and I saw how difficult it was for my mother as well to see her mother forget who she was. And over time, this stayed with me, and I decided that I would like to do something to study this disease and understand how we can keep our brains healthy as we age without forgetting who we are and without forgetting our family around us.
Okay. When you heard the name Mood Omics for the first time, what were your thoughts, and how did you relate to the event that we are attending today?
When I first heard of Omics and the fact that there was art involved, I was excited because I have danced my whole life, and I dance for exercise, and I think it's a very good part of my life to keep my brain healthy, because to remember all the steps and to use your body every day in exercise or every day is incredible. And I love music and I love art, and I ask my children to also participate. So it's very important to me.
Alright, talking about the re-engaging thing that you are studying, and we have already, where do you see this evolving in the next 10 years all over the world specifically?
I think in the next 10 years there will be cures for the disease. The question will be how fast will we be able to get it to the clinic. The issue is that Alzheimer's disease and other neurodegenerative disease studies take a long time to do clinical trials because you have to watch the progression of disease. And we're still trying to find the earliest biomarkers to identify the disease before your brain starts shrinking or deteriorating. And I think that's the biggest challenge. Finding the biomarkers will really help the clinical trials as we move forward.
We are wishing you all the very best, and thank you so much. Thank you. First, and then I'll ask
You want me in Hindi or English both?
Yes, sir, yes, sir.
Jaisa chalega. It's our Indian district, no? That's fine.
So, tell us something about yourself first.
Namaste. मेरा नाम डॉक्टर रश्मि राणा and I'm from Sargagaram Hospital, New Delhi, India. So basically, we are working on brain tumor. तो ब्रेन ट्यूमर एक दिमाग का बीमारी होती है जिसमें दिमाग में गांठ होती है. तो हमने सोचा कि अपना प्रोटियोमिक्स जो ये कॉन्फ्रेंस भी एपीटी एडवांस प्रोटियोमिक्स टेक्नोलॉजी as a proteomics person, why not we doing this as a early detection biomarker. So we find out there is one biomarker that is called galectin-3 binding protein, and that can detect brain tumor in plasma at early stage. And that we have been patented through our government of India, and we have published couple of articles in this. So now we are hoping we can detect brain tumor using plasma samples before any surgery or any clinical management of the brain tumor. And coming to this conference, I would like to thank Professor Sanjeeva Srivastava, who given me this opportunity to meeting eminent professor like Jesus from Harvard, medical school. She is working on neuroscience, and other, eminent professor around the world. And Professor Sanjeeva always having a, moodomics, proteomics, and fun here, science plus cultural things, and we enjoyed. Thank you, Professor Sanjeeva and IIT. Thank you so much. Namaskar.
Thank you so much. So, we'll start with your introduction first, and then I'll ask you a few questions.
Sure. So, my name is Dr. Vipin Nair. I am the head of our School of Biotechnology at Amrita University in Kerala, and I'm also the Dean for Life Sciences at Amrita University. So I've known Dr. Sanjeeva Srivastava for a long time, and the idea of being here at this conference is to just get updated and also contribute to the deliberations that are going on over the past 4 days. Thank you.
So, in short, I mean, जो normal जो जनता है उनको आप क्या बताएंगे about mood omics? What is this exactly, and how people can understand this is something that it has been planned in IIT Bombay?
So, moodomics is just an expansion of omics technologies, जिसे कहते हैं proteomics, metabolomics, transcriptomics, genomics. So, an understanding of the processes that are in place in all living systems, और वो समझने से and getting a better understanding of these processes, we would be able to better understand disease states, better look at how these things, these conditions can be cured, can be diagnosed, and can have a better health situation. So Moodomics is just a expansion of that to bring awareness. देखे होंगे कि there were at least 500-600 students from schools around Bombay who were given that kind of an exposure with quiz and debates and posters and interactions with the experts who are here from all parts of the world and how they are able to impart that kind of knowledge, that awareness, that these are the things that the future generation, these students can look forward to. So a mix of technology and understanding of the latest and the best sort of advancements in knowledge in the sciences.
Fantastic. In the next 10 years, where do you see, I mean, these techniques evolving in India and in the world, of course? In the next 10 years, what can we expect?
So India has taken very rapid strides, very aggressive sort of approach to see that India is also among the top nations as far as advancements in these technologies is concerned in terms of life care because, for example, the Government of India through its Department of Biotechnology has introduced what is called a Bio E3 policy. That's looking at the economy, looking at employment, looking at the environment, and seeing how we can incorporate, how we can depend on, how we can encourage, how we can inspire all the institutions in India, all the research institutes, and bring about that kind of a collaborative network that can help India to also be among the advanced nations as far as healthcare. Already we are aware because what India showed to the world in terms of biotechnology during the COVID pandemic, as all of us know, India was the only nation in the whole world to be able to effectively combat that pandemic. India was also the first nation in the world to be able to have vaccination for the entire population. And then on top of that, we were the only nation in the world to have donated that effective vaccine to over 70 countries across the globe. So that is the power of technology, the power of being able to implement those things right here in India and be on top or as on par or better than the most advanced countries in the world. And it's possible for us to do. We just need to have that change in the mindset that ये ऐसा हुआ तो और कहीं हुआ होगा. नहीं, it is happening in India. It is, as you said, in the next 10 years, we can see India to be, in the words of our Prime Minister Narendra Modi, Viksit Bharat by 2047. That's what.
Just wishing you all the very best and thank you so much.
Thank you so much.
Thank you, sir. Let's start with your introduction first. Tell us something about yourself and then I'll ask you the questions.
Okay, thank you. So, hello. My name is Professor Graham Ball, and I'm the founder and Chief Scientific Officer of a company called Intelligent Omics. Our company looks at the power of measurement of molecules within the human body and using the power of AI. And from that, we can identify the key things that make a disease tick. And from that, we can also identify diagnostics that help us detect disease earlier.
Okay. So the event that we are attending today, Good Omics, how do you relate to this and what is the first thing that came to your mind when you heard the name?
So this is really an interesting event because it blends the thrill of science, but also it brings about culture. You know, many scientists have to have an artistic side as well. Sometimes in science we have to be really creative and have to really try and solve problems by thinking out of the box. And art, music, dance are all forms of creativity which can inspire us to be our muse in order to find new things about biology.
And so, about your specialization in your own respective field, where do you see this getting developed or evolved in the next 10 years? And I mean, how can the world take this?
So I'm a computational biologist. That means a person who uses computers to model and understand biology. Now, with the technologies we have now, we're able to dig deeper and deeper into the mechanisms of biology at the molecular level. Since we sequence the human genome, we can now understand so much more about diseases. And where I see this going, we're going to get more and more data, but more and more depth of information as well. So using approaches like machine learning and artificial intelligence, we can really dig into this data and understand what what the drivers are for a particular disease like cancer. And from this, we can then potentially identify new drug targets. And that process won't take 10, 15 years, as it has done previously. That process maybe will take 2 or 3 weeks. So we can rapidly get to new treatments that are effective and that are screened using the power of IT, and the power of machine learning.
Fantastic. So here's wishing you all the very best and thank you so much.
Thank you.
Thank you so much. Have a good day.
Which I'm a professor at the University of California, San Francisco in the United States. And I'm here to talk about the work in my laboratory where we try to develop new therapies for blood cancers using proteomics as a starting point. And the event today, we're here for the Advanced Proteomic Technology Conference organized by Dr. Sanjeeva Srivastava, and here the Mood Omics event, which is really a confluence of culture and science and emphasizing cooperation and advances in India and how we can work together around the world.
Fantastic. So what is this term mood omics? When you hear it for the first time, what were your thoughts? What is it?
So,
Yeah, that's okay.
it's okay. Okay, audio. So in this case, so what says to me is that omics is basically, this is a scientific term. It's how we study all the different molecules and things inside our body at multiple different levels. We talk about mood, this is the emotion, right? This is what people feel. This is how we connect science and feeling, science and emotion, science and culture. So I think that's really what this event signifies.
And we also know about the techniques of the technology that you guys are talking today about over here. Tell us a bit more about those ideas or those techniques that people can actually get to know about more about those things.
Sure. So basically, what we do in my laboratory in particular is what we try to discover is new ways to treat patients with blood cancer. These might be some diseases you may have heard of, such as multiple myeloma, leukemia, and lymphoma. These affect many, many thousands of people in the United States, many, many more thousands in India. And what we try and do is many of these patients have these cancers, they're very deadly. We don't have enough treatments, we don't have enough cures. So what we try and do is we use these omics technology essentially to identify new targets where we can design and engineer proteins and our own immune cells to attack and eliminate the cancer. And so that's really what we do in my group. Many of the other groups here are also trying to use other omics-based approaches, particularly proteomics, the studies of proteins, to find different therapeutic strategies, ways to treat other diseases that affect many, many thousands of people around the world. And we think it's the most advanced way to do this.
Finally, in the next 10 years, where do you expect these technologies helping the world some way or the other?
Right, absolutely. I mean, I think what we're going to have is so many more detailed pictures of so many different diseases that we're going to be able to have many, many more strategies by which to develop new treatments that we never could have imagined before. And especially now, we're in the era we can marry these very large-scale omics technologies, looking at thousands to millions of different molecules within bodies, with artificial intelligence-based approaches. It's going to take our science and our ability to help human disease to a whole new level that we can never even imagine 10 years ago.
Well, wishing you all the very best and thank you so much.
All right, great, thank you.
I will take one picture.